welcome to this new session hosted by Polestar Industrial IT. Today we will be having a panel discussion along with folks from Cisco around a common concern that many IT managers, OT engineers, and security architects have when approaching IoT technologies for their production plants. In past webinars, some professionals have asked us, is it possible to enable cloud manufacturing securely? How to create a secure connection to ICS, OT systems, and field assets like CNC machinery and production robots without risking these assets? We all know that the Internet of Things is among the technologies with the greatest impact on the manufacturing industry now, especially as remote access to information has become essential for navigating post-COVID dynamics at the workplace. IoT can provide manufacturers access to more data than ever before, fueling a company's transformation efforts. But as there are many links in the security chain of an industrial organization, a single failure can create a devastating impact. Therefore, our customers' concerns we think are real, and organizations must take an all hands on deck approach to mitigate new security risks. So that's why we are here together today. In this session, we will help you realize how, through secure network designs and easy to access and implement industrial grade IT systems, any company from any industry vertical and size can start enjoying the benefits of the digital era in manufacturing. To go through today's agenda, we have brought two experts in industrial networking and security. Welcome Michael O'Malley from Cisco and Julian Smith from our very own Polestar. Guys, please introduce yourselves.
I'll jump in first. Thanks, Mario. So I'm Julian Smith. I am the Managing Director or CEO of Polestar Interactive. And I came from a technical background originally, designing highly secure, available networks. In the last few years, we've worked mostly exclusively with manufacturers, but also lots of folks in utilities and transport and logistics industries, particularly bringing and helping them adopt some of the new IoT technologies.
Great, thanks, Julian. Michael?
Thanks, Mario. And good morning, good afternoon, everyone. As Mario mentioned, I'm Michael O'Malley. I'm one of the IoT Technical Solution Architects here at Cisco. My role really is here to support customers and partners throughout the UK and other countries throughout Europe with any of the Cisco technologies, whether it's in old, new, hybrid industrial networks across the whole of the industrial portfolio. So you'll see today when I run through my session some of the devices that we have, but just remember we're not limited to what you're seeing here. So if there are any questions, you want to know more about what Cisco does in this area or what Polestar can do supporting you going forward, please do reach out. We're here to support you.
Great, thanks Michael. So let's start first discussing a bit on the use cases of implementing cloud manufacturing, IoT, and digitization in general. If any of the attendees have any questions, please just leave them on the chat box. We'll have a Q&A session at the end and we will be answering your questions. So, how IoT systems work. IoT systems architecture, put simple, consists of three tiers. In tier 1 we have devices, in tier 2 we have the edge gateway, and in tier 3 we have the cloud. Devices include networked things such as sensors and actuators found in IoT equipment, particularly those that use protocols such as Modbus, Zigbee, or other proprietary protocols to connect to an edge gateway. The edge gateway layer consists of sensor data aggregation systems that provide pre-processing of the data and connectivity to cloud, using systems such as WebSockets, the Event Hub, and even in some cases, edge analytics or fog computing. The edge gateway layer is also required to give a common view of the devices to the upper corporate layers, to facilitate management. The cloud tier will include applications built using HTTPS and OAuth. It includes various database systems that process sensor data, such as time series, databases, or asset stores. This tier handles communication that go through all the other tiers as well. Cloud manufacturing use enterprise information technologies to function under the support of cloud computing, Internet of Things, virtualization, and advanced computing. The use of cloud IoT, edge, and virtualization enable a hyper-connected factory, resulting in a better network and asset visibility. The extraction and analysis of process data in real time is also enabled, and the option to use AI and remote collaboration systems for advanced data processing is going to become possible. But which could be real world benefits for manufacturer when enabling these capabilities? Well, IoT is pervasive throughout the manufacturing value chain, which affects the four primary strategic priorities for a manufacturer, which are smart manufacturing, that means using IoT and sensors to improve factory performance in the plant, product innovation, using IoT and sensors to improve new product introduction, field service, using IoT and sensors to enhance service offerings and delivery, and finally, supply chain optimization, which is using IoT and sensors to improve supply chain orchestration. Talking specifically about smart manufacturing, digital control systems allow you to automate process controls, operator tools, and service information systems to optimize plant safety and security. IoT can also be applied to asset management via predictive maintenance, statistical evaluation, and measurements to maximize reliability. And well, you can see in this presentation some data collected by Cisco on the benefits that most of our customers are enjoying. Cisco's survey of over 400 manufacturing executives sampled the results of implementing intelligent networking systems, which in general are great downtime reductions, quality improvements, faster time to market, improved OEE, and reduced energy use, to mention just a few of them. So far, it looks so good, but we all know that connecting things to the internet, it brings some risks as well. Julian, you've been working in cybersecurity for a few years now. Could you please let us know about some of the risks that manufacturers could face?
Sure, thanks, Mario. So one of the questions that somebody asked me recently, which was a really good one, was why do I actually need to connect my industrial assets to the cloud? Is there a particular need to do that other than just to see if it's possible, for example? Particularly when you start looking at some of the other industries like C&I, transport, smart cities, and things like that. They're obvious for manufacturing, but not so obvious in some of those other cases, and particularly when thinking things like nuclear and places like that. So ultimately, it comes down to knowing what the use case is. What is the end application? Why am I doing this? Is it for remote access reasons, for support services, or maybe commissioning? Is it so I can get OEE data? Is it so I can learn things from preventive maintenance applications? Or is it so I can use new technologies like VR and AR when service engineers are at the plant or at the facility? So bearing in mind the application requirement, it then comes down to, okay, so if we're looking at the risks around using this particular application, what are the threats? Who are the threats? Am I protecting the plant against? Is this going to be cyber actors? Is it going to be issues with misconfigurations, for example, in some of the settings? So having a bit of a risk analysis approach initially and covering off what those specific risks are is one of the best things to do. And then Also, if we're connecting these assets for a period of time, obviously the longer these assets are connected, the more risk we have. So we need to bear in mind what the lifetime is of those assets. Who's going to be managing it in 8 to 10 years? So management and orchestration is quite a consideration around that, particularly as a lot of our customers are looking at outsourcing some of their services to MSPs who specialize in NOCs and SOCs that can provide that wraparound cybersecurity service as well.
Great stuff. Thanks, Julian, for those insights. But let's be positive. Let's see how manufacturers can get started with a secure digitalization process. From the technology perspective, there are many levels of maturity on the way to connected factories. Digital transformation, as mentioned before, can include industrial IoT, which is connecting things such as CNC machinery, robots, field devices, and other factory things. It can also include remote monitoring and control for better asset visibility. It can include cyber physical systems, which can enable data-driven outcomes thanks to the use of AR, 3D modeling, and digital twins. And companies can take advantage of all of these three digitalization stages. But you need to implement them successfully in one order so you can realize a fully automated future. Many companies have been dipping their toes in the water with POCs for data analytics, and it's not easy to introduce control systems later on in the process. So you need to think of digitalization as a scalable loop. At Polestar, we got 5 stages for implementation, which include first the design of basic computerization and connectivity. The second stage is secure integration of OT and IT layers and departments. Third stage, we connect machines with additional sensors for visibility, leading to digital models of the factory. A fourth stage is the gathering of the right data, doing it transparently in quantity sufficient for meaningful analysis. And the fifth stage is the smart simulation of different future scenarios and identification of the most likely ones, allowing for accurate decision making. That is basically becoming a smart factory. Julia, could you please introduce us to those first steps towards a connected factory? I've heard that to set the foundations of a smart factory, it is necessary to count with a secure by design network. What does that mean?
It's a good question. The traditionally, looking at the Purdue model, for example, where you're partitioning or segmenting the layers of responsibility within your factory environment. Traditionally, the perimeter has often been at the boundary with the enterprise and corporate networks. And traditionally, lots of customers have put a lot of their resource and effort into ensuring that unwanted activities don't happen on the production side of that perimeter boundary, and the right kind of data is coming out into the right applications on the corporate side. So they're getting the information that the business is getting the information that it needs to do whatever it needs to do. With the advent of cloud technologies in the last few years, one of the things that we're seeing is that it's possible potentially to start rethinking about those traditional perimeters. So, for example, by pushing data directly into the cloud from the production system, in some environments, depending on how critical that data is to production, and this might not be production critical data, by the way, a lot of the time. So that enables you to take advantage of some of those cloud services that can allow you to scale your security across multiple plants. So you're building that security architecture once, and if you can build it from that point, you can start building in the security by design, because we all know that retrofitting security into brownfield or existing factories, of which are the majority of factories, is a very difficult thing to do, particularly when you're in the process of manufacturing. So what we've seen is where we can push some of the data from some of these new IoT type technologies, some of the use cases we've mentioned, like OEE, preventive maintenance, etc., into new cloud applications. We're then just focusing on that data that's leaving that factory. It doesn't have to traverse many different layers of corporate security to get to a cloud application that can provide some of those benefits quite quickly to the end users. It also allows for data to go through, let's say, for example, SD-WANs, so that you can have data going out of the production system into a secure cloud environment across multiple sites, then back into the it may be a private cloud system or back into the corporate network itself. So it allows a better degree of segmentation, in my personal opinion, that is, when it comes to some of those non-critical applications, Mario.
Thanks, Julian. So let's continue with the discussion. In the time that I've been at Polestar, I've heard that implementing Cisco Validated Designs offer great value for our customers, especially to improve their connectivity and for security compliance. Could you please elaborate a bit on what this means and what is the impact this have on a manufacturer's network?
So using validated designs, really, it is. I mean, it is a bit of a wild west. I mean, most factories, in fact, every single factory is different. I can't recall any factory I've been in that's been standardized across a particular industry or a particular customer or a particular type of process, basically. What we've been doing in the last 2 or 3 years has been looking at things like overlaying software-defined segmentation approaches, particularly obviously on brownfield sites, where we can move some of the newer application requirements away from some of their existing technology, but also that existing OT technology. But it does give you the ability to start getting some insights and getting visibility into what the actual technology is out there in terms of the existing OT networks, or whether it's IO devices, PLCs, controllers, etc. So having a validated design as a roadmap is a really good place to start. Most factories have a huge number of vendors. Again, standardization is a big driver for a lot of customers at the moment, but every single factory, and generally having the cost center at that local factory rather than, let's say, spread over a geographical region, means that you've had a lot of different providers, a lot of different integrators are involved, and more commonly these days, you're finding that the IT function is becoming standardized across them. But that doesn't always go through unless the customer or the business is looking at some kind of convergence approach. So you need different solutions from different vendors. You need a roadmap, and the validated design means that everybody can get on the same page and start looking for the same goal. And again, putting over something like a software-defined overlay can actually help minimize some of those risks. So what you'll find, of course, is that no one produces the best of class software, hardware, and services to solve all these problems across the plant floor. So you need different components to work together, and the validated design can accommodate the requirements for the different stakeholders, whether it's process owners, whether it's operators, whether it's systems engineers, etc. It allows them to have a common point of view to do that. So with the vendors that we work with closely, like Cisco's got a very large selection of different designs for different industrial use cases that you can use across all of their product portfolio. Some of the other vendors we work with as well that don't necessarily provide all of the hardware to the depth that Cisco can do, but do also work with trusted vendors to provide plant-wide security services across their different service divisions. And again, coming back to seeing some of the companies that are now starting out offering SOC services based on a common hardware platform with OT security solutions that can do that. So yeah, overall, having that roadmap and that common objective, I think, which is, from the business's point of view, at the end of the day, it's to produce, carry on producing what it needs to do. But at the same time, without having a lack of visibility on what the systems they've already got in place, but having a strategy in terms of adopting some of those newer technologies. And we're seeing things like PLCs and these days having a lot of IoT functionality built in. So those designs do provide a very important goal, particularly when you're looking at things and standardizing like IEC 62443, for example, as adopting that standard across your facilities.
Great stuff. Thanks for that, Julian. That's been made pretty clear. I guess then that the next step for establishing a secure and robust network foundation that can help with the adoption of digital technologies should include also secure industrial grade hardware and software. Michael, could you please introduce us to some of the approaches and some of the solutions that you guys have at Cisco, please?
Yeah, sure. Happy to do so, Mario. Let me just share my screen so we can see my deck. But yeah, as I mentioned at the start, and also to complement what the guys have been running through there, what I want to really run through is where we as Cisco can overlay some of this hardware, where we can bring in, as Julian mentioned there, some of the capabilities around standardization when it comes to documents, such as CVDs and so on. And also allow you to build and kind of not necessarily rip and replace. That's the thing we don't want to do, but kind of retrofit where possible and bring in that whole design, thinking and security by design as we're going ahead. Cool. So first we start, I think, around how we allow connectivity from the edge to the cloud. It can be a number of different ways. Some customers are more open to, connecting on their network and allowing, and working with the IT teams to give either direct or filtered access from a platform or a service to the cloud. But in a lot of cases, I mean, Julian touched there on the edge box, which they have, where we can offer that connectivity into a set of solutions or devices without having to necessarily, in some cases, re-engineer the network. What we would typically propose, obviously it has to be kind of off-grid, not necessarily in the dark, hidden from the IT teams, but allowing cellular connectivity or other options so we can kind of bridge the industrial network securely to allow remote access. As you would expect, we do have a complete portfolio of remote access, dependent on the use case, the environment, the budget, you name it, we can offer that. One thing we're very proud to announce, it's the first time for Cisco, is that we do have a gateway or edge device that is able to address every use case. And it might seem odd that we're saying that now, after however many years in the industry, particularly in industrial. But now we do have lower cost gateways, which you can see there on the left, built for smaller, not necessarily cheaper, but devices that are typically deployed at scale. And these devices can only be managed, integrated through the cloud, which allows them to be low cost. But don't for a minute think that we would deploy these in an industrial setting, where there's key industrial processes and operations happening. That's where our bigger, more well-established IR portfolio, our industrial routing portfolio, comes in. And on the right there, you can see we've got 4 brand new products that we've launched. And why I say they're brand new, they offer connectivity first and foremost, but we've taken all the best capabilities from the enterprise space, again, leveraging the skills that the IT teams have, and enclosing them in ruggedized housing. So all the benefits around high-speed wireless, serial connectivity, we think of large utility networks where we need lots of different types of connectivity. We can offer that now in a single box. But we can also offer that secure remote connectivity, the mass scalability as well. So if you want to deploy not just 1 or even 10, we don't have to re-engineer the solution. We can use the right management tool from the start, whether it's an IT tool like SD-WAN or DNA Center, or we may want to choose something that is more built for the industrial environment. I mean, it doesn't look ruggedized or industrial, but it's built for secure, simple connectivity at scale. And we do have 2 flavors, and this really is down to you guys as a customer. Are you on that journey where you want to start doing more cloud? Are you reticent, of doing anything on the cloud? You want to do anything on premise? So we do have 2 tools which we can use. The first one being an IoT operations dashboard, which allows that seamless deployment. So when you get the device from Cisco, you simply plug it in, and then we can manage it securely over the internet. But don't think, again, for a minute, we're sending any secure data over there. There is a tunnel that we use just for management. Everything else stays on premise, the same as remote access, and we'll cover that in a second. When we want to go down the full secure route, where we don't want anything on the internet, we do have an on-premise solution called Field Network Director. All the same benefits of zero-touch plug-and-play, software management, template-driven configuration, which is a key. We can do that on both, but we with the benefit of having cloud or on-premise. I mean, just to really elaborate on IoT operations dashboard, we're seeing great traction with this right now, where we can very quickly deploy a complex asset as a Cisco iOS XE based device at scale, giving you all of the benefits around security, application hosting, and so on from one single cloud platform. The great thing is that if you are starting on that journey and maybe you want to add more services and do a bit more with your assets on site, we can start to enable them in the platform. So again, it's not a case of rip and replace. We can deploy applications at the edge. One of them being Edge Intelligence, and another one is our LoRaWAN based solution, where maybe you don't want to replace this PLC or controller. You want to retrofit and add some more sensing. All of this is in one central platform. But as I said about remote access, I mean, a lot of the assets that you may have in the field, you don't ever want them to touch the internet. Think of Windows 7, Windows XP, very old devices, not for the sake of it. They may be very specialist piece of software running on there that you don't want to run the risk of, completely killing the OS just with an update. And this is where our secure equipment access comes in. It's a small application that runs inside of the gateway, which allows web-based connectivity on a number of protocols: web, remote desktop, telnet, and soon to becoming a one-to-one mapping. So think of your support teams, think of the engineers that want ad hoc access. There's no need to work with security teams or firewalls and so on to be able to grant that access. We can do it with with a number of clicks, and we can do it all over the web, not using any custom software. So that's a really cool feature that we have. So I guess now we come on to security. I mean, this has to be and it is at the forefront of every decision when it comes to deploying new sites. When we see all the enhanced or all the increase in attacks that we're seeing across the industries, with right now industrial and utility networks being one of the key targets. But as Julian touched on, we can't really secure what we don't know about. So getting that visibility into what you have, not saying that you guys won't have an accurate recording of assets, but being able to see things like serial numbers, software versions, and so on. We want to be able to do that so we can then correlate this with other information sources, vulnerability databases and so on. Who's speaking to who? What asset is talking to what device? And being able to understand the patterns of how machines work. I mean, business may still be working, still operational 24/7, but who is watching when that random device connects in the middle of the night for a few minutes, starts to remove some data or make any changes, this is where we want to get that enhanced visibility. But I think one of the key things is we can't just immediately tomorrow go in and say, right, we need to put firewalls in and start to lock things down. It has to be a journey. Again, starting with those sites which are already operational. Again, it may be a greenfield site where you want to build onto it. But we want to leverage all of the tools and the expertise you may already have on the IT side of the house and bring this over to the OT operations. Step one there, we mentioned in the previous slide around being able to get visibility, understanding the assets, who they're speaking to, what they're doing. The next step will be around segmentation. We're seeing devices maybe bridging over from the IT to the OT network. We're seeing remote actors. We're seeing Windows devices speaking out to the software update services. How can we lock them down without impacting the output or the performance of the factory? Then going forward, this is where we bring in the real smart stuff. We've got a baseline, we understand what's happening on the network. Now we want to be able to alert and build real integrations into other tools. Whether it's using IDS, or intrusion detection systems, to see any malicious or anomalous traffic. Whether we want to monitor Windows devices or some of our engineering stations, they maybe start asking for variables in lab networks, POC areas that they shouldn't be even working on. So these will be picked up. But the final goal there is really bringing that tighter integration between the IT teams and, more importantly, the IT tooling that they use. Whether it's alerting systems, security software, more of the scene platforms where they can correlate lots of logs. You'll all be too familiar with seeing some of the news around some of the attacks, where the vulnerability is actually spread from the IT network into the OT space. So this is where we can glean some of the intelligence, the best practices, and start to apply them in the manufacturing environment. So where do we come in here? Cisco Cybervision is one of our newer products in the portfolio from an acquisition called Centrio, and we can offer all of this visibility and the enhanced insights into how the business and the systems are working. So things like serial numbers, product information, right the way down to any of the vulnerability and risk scores from the assets, we can do that. But the key thing is around that threat detection, that next step. It's in there, it's monitoring. How do we understand and see any failures or anomalous traffic on the network? We do it in a different way. There's lots of products out there in the market, and on face value, this will seem the same as some of the other products that you've seen. We have sensors out in the field collecting data, sending them back to a central station. But in our case, we have the benefit that we're reusing, or we're able to deploy hardware that can start to collect the data at the edge, do the processing, and send this back to a central station without the need of maybe overwhelming, already close to being oversubscribed links. So we're not, replicating and building a new span network. We're doing it on the edge, inside of the networking equipment where possible. If not, you will see how we can do this in a retrofit way, or even if you wanted to do a proof of concept or proof of value, we have hardware and tools to be able to allow us to do that. From a hardware and software perspective, just very quickly, I mentioned we can reuse the networking equipment. So from the enterprise switch we see on the right-hand side, there are clean environments out there where they're using enterprise hardware, but we also have the routing platform, the IRs, as well as our industrial networking portfolio. As I mentioned, around being able to retrofit or go in there and do an assessment or an audit, but also these are used in production where you can't replace the hardware. This is where our dedicated hardware sensor comes in. Takes the traffic and then does all the processing right the way at the edge, sending it back to our Cybervision center. Just around the visibility, it's very simple to use. If you get the opportunity, either on Cisco dCloud or even follow up, we can work with you to show it in action. You get a very comprehensive report of your network and everything that is on there. So it's not a snapshot, it's not a spreadsheet showing last week we had these assets. Everything that changes on the network, down to host names, IP addresses, even daughter cards being inserted into products, they will show up there. From the vulnerability detection, we internally at Cisco have our Talos arm. So these are one of the, if not the world's biggest independent security agency. So we get all of the feeds from there around vulnerable and risky IP addresses and malicious signatures when it comes to snort signatures. But then a really important thing is a risk score. So a risk score is what we can assign to assets. And it's built on two metrics. How exposed is this device? So is it talking to the internet? Has it got access to the internet? And secondly, what vulnerabilities exist? So say, for example, it's running an SMB vulnerability and it's talking on the network or IT assets of connectivity. This will be classified as a very high risk asset. The good thing is that we can then offer kind of a target where you guys can aim to. You may be at a high 70, but we will show you the steps that if you want to move closer to the green, do these certain operations. We mentioned around operational insights, so who's speaking to who, what variables are being read and written from devices. This extends out to the IT network, so we can see a lot of the SNMP traffic, any of the management traffic going around, and give that in a very easy way to consume. But the final one is around some of the anomaly detection and vulnerability assessments. So when it comes to anything new on the network, whether it's a new IP address, a new module, or even if it's a new variable being read, all of this will be flagged up in the system in red. And this is where the integrations really come in. Feeding this information back to IT, who in most cases are responsible, even though they probably don't claim to be. This is where we can share that information in a very meaningful way. But just to finish up really, and again to kind of reiterate what I said at the start of the security section, it may seem like that Cybervision is very similar to a lot of the other products out there in the market. But when we compare and talk about some of the benefits, such as being able to run this inside of Cisco hardware, which could already be inside of the network, the real power comes to the integration and that close relationship that is built between IT and OT. By itself, face value, we are, if not very similar to the competition. But now we bring in other tools, when it comes to deploying security policies, segmentation, building those integration into other IT assets. This is where we really excel, sharing the information into security policies so better rules can be built, integration into our Talos signature database, where we can get the most up-to-date information right the way to the edge so you're never exposed. So that's it from me. I think guess it's back to you, Mario. But as we said at the start, a lot of information there. Please do ask any question.
I very much appreciate your presentation, Michael. Speaking of edge systems, Julian, you mentioned earlier that implementing edge solutions is a step towards IoT and achieving digitalization capabilities in a factory. Could you please introduce us to the benefits of the industrial edge and how manufacturers can scale up and enable IoT later on?
Certainly. So, what we've seen in the last few years is most people have been dipping their toes in the water with IoT technologies, and we've seen people doing great things with just putting in things like Raspberry Pis and then getting data on a dashboard or on a screen in the factory. On the other end of the scale, we've seen customers with running hundreds of proof of concepts, testing IoT in many different geographical regions. So it's really been very educational, I think, for everybody. But the challenge is for everybody, whether you're an SME or whether you're multinational manufacturer, is how do you then take some of the lessons that you've learned from that and scale up, and how can you do that quickly, particularly with the challenges that we've had in the last 2 years, and we're continuing to have with things like semiconductors at the moment. So so doing a rollout for an IoT application or service, basically, in a managed way is a challenge. So where we've seen some of the benefits being realized is actually at the edge of the network, because companies can have the best of both worlds. They can rely on local data processing within a safely defined area. Also, because everybody's running different systems anyway, and where you're starting to get into control systems as well, it's not easy for everybody to have the same level of capability within their organizations. If you get, a good question that is often asked is, if you have an engineer working in one facility, can they go to another facility within that organization and just pick off where what they're doing there? And it's not easy to do that, particularly as everybody has different PLCs as well. So the edge seemed the logical place to start realizing some of those benefits of being able to do some local data processing safely in production areas down to those automation levels, and then pushing some of that data into the cloud to realize benefits with things like preventive maintenance, as we've said. So smart manufacturing can then start to be done at a managed scale, instead of having to consider what do we do with all of these large amounts of data that we're processing here. Storage and data transmission is vastly reduced if you're doing things at the edge.
Great stuff. So some of the use cases, can you let us know? You were mentioning asset visibility, predictive maintenance. What else can we do with edge solutions?
So yeah, so really where we got to with this is we started, as everybody should, of course, is actually what is the problem that you're trying to solve here? Is it trying to get data from something that's a legacy, something that was never designed to be connected to something else, something that's actually insecure, so you can't easily get data from it? So we then came down with this list of problems that you're seeing here, and then started looking at what was out there from a technology solution that may help with that. And bearing in mind that it's not always going to be a technology solution that will solve your problem, but it goes a long way to helping you visualize and then interpret what that problem is. So really it came down to these problem types and use cases. So we decided that in order to realize some of these benefits, what could we do with these technology solutions that could get customers very quick return on investment? And it really came down to, okay, if we're not taking all of the data off premises, then we can put a security wrap around this, take care of that really big elephant in the room right now. And also, if we're looking at future proofing what we're trying to do here, it's not just about analytics today, it's about, in the future, automation and control. We want to be able to orchestrate using that the analytical data that we've done to then automate some of those decisions, and therefore push some of those control capabilities back into the plant. So the edge is the place where you can maintain the control on that, and of course you don't have the latency issues that you potentially have when you're starting to move some of that decision and automation off premise.
Amazing. Thanks, guys, for your wonderful presentations. I hope this has been of great use for the audience. I guess that's all for today. Thanks a lot, Michael and Julian, for today's session, and to the audience for attending. I hope to see you in future sessions.